Hello everyone, this is a question which is there in GATE 2014 physics paper, and this is question number 10, which states that for a gas under isothermal conditions, its pressure P varies with volume V as P is proportional to V to the power minus 5 by 3. So P is proportional to V to the power minus 5 by 3. Now what we need to calculate is the bulk modulus B, which is proportional to, these are the four options which are given. So we need to understand the bulk modulus, and then we have to proceed for this kind of relation if it exists in between pressure and volume, as we can see from the proportionality sign that P is proportional to V to the power minus 5 by 3 is not a kind of an ideal gas for an isothermal condition. Because had it been an ideal gas, it will be P is proportional to 1 by V. P is proportional to 1 by V. Okay, to understand this solution, let's... Okay, so given condition is that for a gas under isothermal condition, this is the thing which is given. Now to find out the bulk modulus, concept is the properties of the bulk matter. Now bulk modulus is defined as the normal stress, it is the ratio of the normal stress to that of the volumetric strain. Now what is a stress? Stress is the restoring force per unit area. So from the outside, if the force per unit area is applied into a particular volume, then the restoring force to come back into its equilibrium position or original position, whatever the restoring force is applied by this body is nothing but the stress. Strain is the change in the dimension to that of the original dimension. So this is the definition of the strain. So suppose this is the volume, this is the actual volume, V. Now if from outside the pressure is given, capital P is the pressure from the outside, that is nothing but the normal force per unit area. Now this decrease, the volume of this decreases, V minus delta V, the volume decreases. Now what is the strain therefore? The volumetric strain is delta V by V. Now the restoring force per unit area is opposite to that of the pressure. Therefore, we write the normal stress is minus P, strain is delta V by V, and B becomes minus P divided by delta V by V. In the differential limit, we can write the bulk modulus as minus V delta P delta V. Now we will use this particular formula to proceed further. Now given in this question is that P is proportional to V to the power minus 5 by 3. So I can write it equal to K into V to the power minus 5 by 3. Now delta P by delta V I need to find out. So for that I differentiate it with respect to volume partially. Although you can do it as dP dV because it is the only proportional, it is only proportional to the volume. Therefore minus 5 by 3 K V to the power minus 5 by 3 minus 1. And we get this as minus 5 by 3 K V to the power minus 8 by 3. Now, what is actual the bulk modulus is minus V delta P delta V. Therefore, I multiply it with minus V, and this is the delta P delta V expression which we have found out. Based on that, if I further solve, it comes out to be ultimately 5 by 3 K V to the power minus 5 by 3. Therefore, what we get is that the bulk modulus B is proportional to V to the power minus 5 by 3. Therefore, option D is the correct option. Let's see. Yes, option D is the correct option for this particular problem. Thank you.